Yeah, we're going to have a look at using the product rule to differentiate two different types of functions, both parts A and B. So in some questions, you might need to use the chain rule with the product rule, and I've specifically chosen those types of questions here. So let's do part A first. So first of all, how do you know whether you have to differentiate using product rule or so on and so forth? Well, whenever you have two different functions multiplied together, like here we have x squared multiplied by root 2x plus 1, that's where you use the product rule. You call one of the functions u, and you call the other one v. Try not to get tricked with something like 5 root 2x plus 1. 5 doesn't really count as a function, it's a constant. And so here you use the chain rule, which I'll talk more about why later. So first of all, we mentioned we call one of the functions u, and the other function root 2x plus 1, v. Let's call that 2x plus 1 all to the power of a half. You'll see why that helps later. Before you do the rest, we see that on the right hand side of the equation there's dv dx and du dx, so you want to find those. So du dx is what you get when you differentiate u with respect to x, which is just 2x. And there's a little trick here to using the chain rule. By the way, there's a video I made about how you can know whether to use the chain rule, but just in general, whenever there's a composite function, so like here there's a function of 2x plus 1 inside of x to the half, and that's what gives 2x plus 1 all to the half. That's where you use the chain rule. So you can take the power, you can multiply it by the coefficient on the front, which is just the 1 in this case. You then, oops, let me write that out nicer. You then differentiate the inside of the bracket, which differentiates to 2, and then you rewrite out the bracket and you subtract 1 from the power. So half to equal 1 is minus a half. 2 times a half is 1, so this just becomes 2x plus 1 all to the power of minus a half. Perfect. Now we just input into the right side of the equation. So we have u, which is x squared, multiplied by dv dx, which is this here, 2x plus 1 all to the power of minus a half. And then plus v, which is 2x plus 1 to the half, multiplied by du dx, which is 2x. You can't really go anywhere from there, because you can't multiply these out. If this was a power of 1, then you can multiply out the brackets. Same with the second term here. So you just leave that as it is. Moving on then, let's do part B of this question. So again, we have two different functions that are being multiplied together. We have the function x multiplied to ln x plus 1. So let's call one of them u. By the way, it doesn't matter which one you call u and which one you call v. And let's call v ln x plus 1. Now du dx is going to just be equal to 1. And let's use that same method, but in a more difficult case here. So I mentioned you take the power, you multiply by the coefficient. This is just the power of 1, so you multiply it by 1. You differentiate the inside of the bracket. So x plus 1 differentiates to 1. Actually, I want to show you a different way of differentiating this using chain rule, because this one's a little bit more difficult. So just in general, when you're using the chain rule, you want to replace the bracket with a singular letter. So let a equal x plus 1, in which case v is equal to ln a. And then what we want to find is dv by dx. But we find that in terms of a. So we say it's equal to dv dA multiplied by dA dx. We can find dv by dA by differentiating this equation that we formed relating v and a. So ln of a just differentiates to 1 over a. That's what dv dA is. You can find dA dx by differentiating this expression that you formed for a. So dA dx is just going to be equal to 1 because x plus 1 differentiates to 1. We then multiply these together to get 1 over a times 1, which is, so let's write that out. Multiply together gives you 1 over a as well. And then you can replace a with x plus 1. So it's just 1 over x plus 1. I think that was the hardest part of the question. From there, you just sort of put into the right hand side of the equation again. So you have u, which is x, multiplied by dv dx, which is 1 over x plus 1. Sorry, it took me a while to find it. And then plus v, which is ln x plus 1, all multiplied by du dx, which is just 1. Again, you can't really go too far with this. You can, I guess, to multiply the tops of these two fractions to get to x over x plus 1. But that second term, you just sort of leave it as it is. And that's everything for this question. Hopefully that made sense. And if you have any questions with it, just let me know in the comments. That was more like a brief introduction on how to use the product rule. If you'd like me to go through more difficult questions on the product rule, just let me know in the comments. And yeah, thanks for watching. Be sure to leave a like and subscribe.